Good morning. In today's class, we will discuss how to extend the range of an voltmeter. So, in order to extend the range of an voltmeter, a resistance is connected in series with your meter resistance, where the series resistance is called multiplier. Where the series resistance is called a multiplier. Series resistance is called a multiplier. So, in order to increase the range of an voltmeter, what we have to do is, we have to connect a series resistance or a resistance in series with your meter. So, let us assume a resistance Rs, is connected in series with your meter, where the full scale deflection current or the current flowing through the meter is Im, and the resistance of the meter is Rm, and the voltage across the meter is Vm, right? And the increased voltage quantity or the quantity of voltage to be increased, or the quantity of the voltage to be extended, is equal to V, right? Now what are the assumptions we have made? We have made few assumptions which are nothing but a series resistance Rs is connected in series with the meter, where Rs is the series resistance, Im is the current through the meter, Rm is the resistance of the meter, and V is the voltage range of extension. V is the voltage range of extension or the extended voltage range, and Vm is the voltage rating of meter. This is nothing but the initial rating of the meter, where the initial rating of the meter should be extended to a value of V, right? Now, in order to calculate this, we will apply mesh analysis. That means I am applying mesh analysis for this circuit. So when you apply mesh analysis for this circuit, what you will get? You will get V equal to Im Rs plus Im into Rm. We will get V equal to Im into Rs plus Im into Rm. So where V is nothing but the voltage of the meter to be extended. So from this equation, we should calculate the value of Rs. So what is the value of Rs? So the value of Rs will be equal to V minus Im Rm by Im, which is equal to the value of Rs. That means the value of Rs is equal to V minus Im Rm by Im. So when you further simplify it, we will get the value of Rs is equal to V by Im minus Rm. So this is the value of your series resistance value. So as we know that the multiplying factor of the voltmeter is nothing but M. So M is nothing but the multiplying factor of the voltmeter, where the value of M is equal to V by Vm, where the value of multiplying factor M is equal to V by Vm. So as we have already calculated the value of V, where V is equal to Im into Rs plus Im into Rm. Now we have to know the value of Vm. So what is the value of Vm? Vm is nothing but the voltage across the meter. So what is the value of Vm according to Ohm's law? So the value of Vm according to Ohm's law is equal to product of the resistance into current. Vm is equal to the product of resistance into current. So let's substitute here. So this is equal to, what's the value of V? Im into Rs plus Im into Rm divided by the value of voltage or the voltage across the meter. Vm is equal to Im into Rm. According to Ohm's law, the value of Vm is equal to Im into Rm. So Im into Rm. So this is nothing but the multiplying factor of the meter. So when you simplify it, what you will get? M is equal to Im into Rs. M is equal to Im into Rs by Im Rm. I am doing the simplification here, where M is equal to Im into Rs by Im into Rm plus Im into Rm divided by Im into Rm. So this term gets cancelled. So now what you are getting here? Im is also getting cancelled. So M is equal to Rs by Rm. M is equal to Rs by Rm plus 1. Why? Because Im gets cancelled here. So the value of Rs is equal to, that means I am simplifying this term. So the value of Rs is equal to Rm into M minus 1. So the value of Rs is equal to Rm into M minus 1. Right? So this is nothing but the external resistance which must be placed in series with your meter resistance in order to increase the range of the voltmeter. That means the series resistance value Rs is equal to Rm into M minus 1. In the case of multi-range voltmeters, now in the case of multi-range voltmeters, now in the case of multi-range voltmeters, what we consider? We consider n resistors are connected in series in order to have different ranges of extension. That means we will have different resistors connected in this fashion in order to measure various ranges of voltages. That means we will have resistances R1, R2, R3 of different values, and the meter resistance is nothing but again Rm, and it is having a current of, or flow of current is nothing but Im. So in order to measure different values of V1, V2 and V3, that means I can measure a value of V1, V2 and V3 with this type of construction. So I will place a switch over here, right? So when the switch is placed like this, that is S1, when the switch is S1. So when the switch is closed at position 1, we can measure a voltage of V1. And the similar way, when the switch is closed at position 2, we will measure a voltage of V2. Similarly, when the switch is closed at position 3, we will measure a voltage of V3. That means with this type of construction, we can measure 3 different ranges of voltage. That means when switch is at position 1, where R1 is connected in series with Rm. Similarly, when the switch is at position 2, R2 will be in series with your Rm. Similarly, when the switch is at position 3, then R3 will be in series with your Rm. So when the switch is at 1, you will get a value of V1. When the switch is at 2, you will get a value of V2. And the switch is at 3, you will get a value of V3. So you should calculate the values of R1, R2 and R3 in order to increase the voltage range from Vm to V1, V2, V3. Again I am saying, in order to measure the voltage of V1, V2 and V3, we are increasing the range from Vm to V1, Vm to V2 and Vm to V3. That means in order to increase the voltage range from Vm to V1 or Vm to V2 or Vm to V3, we are placing three different resistors R1, R2, R3. So when the switch is at position 1, you will get a value of V1. When the switch is at position 2, you will get a value of V2. When the switch is at position 3, you will get a value of V3. That means you are extending the ranges to V1, V2 and V3. So in order to extend the ranges to V1, V2 and V3, you should calculate the values of R1, R2, R3. That means these are nothing but the series resistances which must be placed in series with your meter in order to extend the range to V1 or V2 or V3. So the value of R1 is equal to V1 by Im minus Rm. In the previous case, we have discussed for a single extended range meter. That means in a single extended range meter, we have placed the resistance of Rs over here. Then you got the formula as Rs is equal to V by Im minus Rm. But in this case, you are placing a resistance value of R1. So R1 value will be equal to V1 by Im minus Rm. Similarly, R2 value will be equal to V2 by Im minus Rm. Similarly, R3 value will be equal to V3 by Im minus Rm. So if there are n resistors connected over here, then the value of Rn will be equal to Vn by Im minus Rm. Now we will discuss a problem on extending range of voltmeters. So in this problem, a MC instrument gives a full scale deflection of 40 microamps and the internal resistance of the meter is around 500 ohms. If the meter is used for a range of 0 to 10 volts, then he is asking you to calculate the value of series multiplier. So let's solve this problem now. So the given values are nothing but an MC instrument is having a full scale deflection of 40 microamps. That means he has given the value of Im is equal to 40 microamps. And in the similar way, the internal resistance of the meter is, that means Rm value is given. Rm is equal to 500 ohms. And the meter is used to have a range of 0 to 10 volts. And the meter is having a range of 0 to 10 volts. That means V is equal to 10 volts. Now he is asking you to calculate the value of Rs. So what is the formula for Rs? We know the formula for Rs. Rs is equal to V by Im minus Rm. The formula for Rs is equal to V by Im minus Rm. So the values are already given. V is nothing but 10 volts. That means the meter range must be extended to 10 volts. Im is nothing but the rating or current rating to the meter, which is nothing but 40 microamps, and Rm is nothing but the internal resistance of the meter. So this is equal to, when you are solving this, V by Im value is 40 microamps, 40 into 10 to the power of minus 6, minus Rm value is 500. So when you solve this expression for Rs, you will get the value of Rs is equal to 249.5 kilo ohms. 249.5 kilo ohms. That means the value of Rs is equal to 249.5 kilo ohms. That means you have to place a series resistance of 249.5 kilo ohms in series with your meter, in order to measure a value of 10 volts. That means to measure a value of 10 volts, you should place an Rs value of 249.5 kilo ohms in series with the meter, where the meter resistance is 500 ohms and the meter can measure a current around of 40 microamps. Right? So this is a simple problem regarding the calculation of Rs. We will calculate the value of Rs by using a simple relation, that is Rs is equal to V by Im minus Rm. Now we will discuss another problem regarding the same principles. So see, an MC instrument gives a full scale deflection of 20 milliamps. It is giving a full scale deflection of 20 milliamps, right? And the potential difference across it is 200 millivolts, and the potential difference across it is 200 millivolts. And he is asking you to calculate the value of RSH if the meter is used to be measuring a current of 0 to 200 amps, and it is asking you to calculate the value of multiplier resistance if it is measuring a voltage of 0 to 500 volts. That means he is using the same meter. He is using the same meter in order to measure a current range of 0 to 200 amps, and he is using the same meter to measure a voltage range of 0 to 500 volts. So in order to calculate this, we should know the value of Rm. In order to calculate this, we should know the value of Rm, where the value of Rm is not given. But he has given the value of Vm into Im. He has given the value of Vm and Im. So according to Ohm's law, what's the formula? We have Vm is equal to Im into Rm. According to Ohm's law, we have the formula Vm is equal to Im into Rm. So when you are substituting these values, you will get the value of Rm is equal to Vm by Im. Rm is equal to Vm by Im. So which is equal to 200 millivolts by 20 millivolts. So which is equal to 10 ohms. That means the value of Rm is equal to 10 ohms. That means the resistance of the meter is 10 ohms. That means he is given the value of the meter resistance Rm is equal to 10 ohms. Now he is asking you to calculate the value of RSH. He is asking you to calculate the value of RSH when it is measuring a current of 200 amperes. He is asking you to calculate the value of RSH if the meter range has to be extended to 200 amperes. So what's the formula for RSH? As you know, RSH is equal to Im into Rm by I minus Im. So this is the formula for RSH, as we know. So the formula for RSH is equal to Im into Rm by I minus Im. Now we'll substitute the values here. So what's the value of Im? Im is nothing but 20 milliamps. 20 milliamps into Rm value is nothing but 10, which you have calculated here. Rm is equal to 10 by I minus Im. So what is I? I is nothing but the extended range. I is nothing but the extended range, which is nothing but 200 minus Im. Im is nothing but the current rating of the meter. So Im is nothing but 20 milliamps. So when you solve this for RSH, you will get the value of RSH is equal to 0.001 ohms. You will get the value of RSH as 0.001 ohms. That means you will place a shunt resistance RSH is equal to 0.001 ohms in order to measure a voltage of, in order to measure a current of 200 amperes. In order to measure a current of 200 amperes. That means when you are placing an RSH value of 0.001 ohms in parallel with your meter, you will measure a voltage current extended range of 200 amps. And then the second question is asking you to calculate the value of RS. He is asking you to calculate the value of RS. That means you will connect a series resistance in order to extend the range of this meter to 500 volts. Now what is the formula for RS? RS is equal to V by Im minus Rm, right? So where V is nothing but the extended range of voltage, which is nothing but 500, and Im is nothing but the current through meter, where Im is equal to 20 milliamps, and Rm is nothing but the resistance of the meter, which we have calculated already, where Rm is equal to 10 ohms. Now we will substitute the values on this formula. So Rs is equal to V is nothing but 500 by Im is nothing but 20 milliamps minus Rm value is already calculated, which is nothing but 10 ohms. So when you solve it for Rs, the value of Rs will be equal to 24.99 kilo ohm. 24.99 kilo ohms. That means you will place a resistance in series with your meter. You will place a resistance in series with your meter where Rm is equal to 10 and your value of Rs is equal to 24.99 kilo ohms in order to measure a voltage of 0 to 500 volts. Right? That means we are calculating the voltage ranges and current ranges of the same meter to be extended to 200 amperes and as well as to 500 amperes. So in order to extend the current range to 200 amperes, we should place a shunt resistor, and the value of shunt resistor is given by the formula Im into Rm by I minus Im, where Im is nothing but the current through meter, Rm is nothing but the meter resistance, I is nothing but the range of the current to be extended, which is nothing but the 200 amps, and Im is nothing but again the full scale deflection of current in the meter, which is nothing but 20 milliamps. So when you solve for RSH, you will get the value of RSH as 0.001 ohms. That means when you place a shunt resistance of 0.001 ohms in parallel with your meter, then you can measure a current up to a range of 0 to 200 amps. In the similar case, when you calculate the value of Rs in order to extend the range of voltage to 500 volts, how you are calculating? You are calculating with the formula as Rs is equal to V by Im minus Rm. Rs is equal to V by Im minus Rm. So we will substitute the values of V, Im and Rm in the above formula. So when you solve this expression, you will get the value of Rs as 24.99 kilo ohms. That means when you place a resistance of Rs is equal to 24.99 kilo ohms in series with your meter, then it can measure a voltage range of around 0 to 500 volts. Right? In the similar way, when you place a value of RSH is equal to 0.001 ohms in parallel with your meter, then it can measure a current range of 0 to 200 amperes. It can measure a current range of 0 to 200 amperes. So I hope you are clear with this concept. Thank you.